UCL-Energy Institute. And before I actually introduce our speaker, I would like to start with some housekeeping information. So there are no fire drills planned. So if we hear one, we have to leave the building. The doors are just behind you. The one that you use to enter the building, and there's one over there. And it's actually the talk of Robert will be 45 minutes long, and then we will have some time for questions and answers, about 15 minutes. But we would really like to invite you to continue asking questions to our speaker, as well as talk to the UCL-Energy Institute members. So for this reason, we have drinks on the first floor after the speech itself. So please do join us. And the only problem is that if you stay a little longer than 7 o'clock, so the doors of the building will be closed. So what you have to do is you have to find the UCL-Energy Institute member, talk to him about energy issues, and then they will let you. So there's lots of us from the institute here, so they will to leave the building. And
they're very friendly, so you can stay. It's not that bad, yeah.
And it's my great pleasure actually today to introduce Robert Lempert, and it's a great pleasure for us to have you here. And Rob came all the way from the US, from Santa Monica or Los Angeles, where he's a senior scientist in RAND Corporation and also a director of RAND Pardee Center for Long-Range Global Policy and the Future Human Condition. Sorry, I have to read it.
So do I.
And it's actually Rob in his career, his research focuses on decision making under deep uncertainty, and especially in the fields of climate change, energy, and the environment. And he has assisted numerous natural resource agencies on decision making, on managing uncertainties. For example, these are institutions in the US like California Department for Water Resources, or as well as, for example, in Vietnam, Ho Chi Minh City on flood risk management. In addition to that, also, Rob is a lead author of IPCC Group Working 2, Fifth Assessment Report, which is just about to come out.
This week, yes, yeah.
And he's also the lead author of the US National Climate Assessment. And actually, when it comes to the UK and UK climate policy or energy policy, so we all think for the next 35 years until 2050 when we have the climate targets. It's really lucky we have Rob here, because while in the UK the world stops at the year in 30 years. So Rob is also an author of a book called Sheppard.
Next 100 years, yes.
And the subtitle of this book is New Methods for Quantitative Longer-Term Policy Analysis. So it's really great, Rob, to have you here. And Rob also came here to join us tomorrow for the workshop we have at UCL together with Siren in France on energy scenarios and all innovative scenario techniques. And so we are really lucky to actually that you agreed to give a talk. So looking forward.
Yeah, well, thank you very much. Thank you for the kind introduction, and thank you for coming out today. So I'm going to talk about some work that we've been doing, taking some of the methods for informing long-term decisions, for decision-making under what we call deep uncertainty. I'll say a little bit about that. Combine it with some agent-based modeling work and try to look at some issues which I think are very important when you think about climate policy, but sometimes tend not to get highlighted by the modeling. And so this is in some ways kind of a very cynical take on the set of issues. Hopefully it's also has some hopeful aspects. And then I should also say that this is a version of a talk that I first prepared for an American audience. And so in a number of places, I use pictures of particular individuals and little vignettes, which are very American focused. And I was thinking about whether I should try to expand that, but I figured that the dangers of sort of getting all the subtext wrong exceeded that. So I stuck with my example. So you'll see what I mean as I go through. Okay, so climate change policy, we organize around long-term goals. You mentioned the 2050 goal for the UK. Our world's governments have pledged to hold temperature increases below 2 degrees C, and then a variety of nations and other locales have made their own pledges, and so that is, as you all know, Arnold Schwarzenegger, who was our previous celebrity governor, and he was actually a real innovator in climate policy. So California has its targets as well. I hadn't realized when I put this up that Celine was going to be in the audience, but this is Celine's this wonderful piece called "To See or Not to See," which she published with Stefan Holgat last 2 years ago, which basically looks at what one needs to do, how fast one would have to decarbonize to hit the 2-degree target. And the basic story here, which I'm sure many of you are familiar, is that you have to go quite fast to hit the targets, particularly the longer we wait. So, as the title says, there's a significant distance between the aspirations, our long-term goals, and what we actually people put in place in policies. And if you go through national emissions reduction pledges and so forth, they fall short of required. And this chart here I won't go through in any detail, but to hit there's a 2-degree target, 2.5-degree target, and this just compares the year when global emissions peak, and how fast the decarbonization rate needs to be after the peak, and then compares to sort of here are the EU and US pledges. Here's the French nuclear program, which is I think the fastest non-depression decarbonization that people have gone through. So I mean, hitting these targets is going to be a challenge. And so this dissonance is not unsurprising. And if you think about long-term policies, there's a number of reasons why they are hard. And this one in particular is hard. There's this asymmetry in costs and benefits. Some of the main benefits accrue to people far future. Some of the costs seem to apply now. This idea of time inconsistency, which is really going to be the focus of what I'm looking at here, which is that what does it mean for policymakers today to commit people decades from now to a target, and how does that actually work? And there's real incentives to kind of push the hard tasks off into the future, and then there's large uncertainties which make this disconnect between current action and future outcome. So people obviously recognize these, and there's a variety of approaches. So this is one of my sort of all-American galleries, but of thinking about how do you take action today which affects long-term emission paths. And so that's Bill McKibben, and he's got 350.org, and essentially what he's trying to do is change norms. Okay, and if people's norms change, that clearly that endures over generations. This is others promote technology transformation. If we transform our technology in radical ways, that has long-term, decade-long impact. So this is Ted Norshaus and Mike Schellenberger of the Breakthrough Institute. And other people figure, well, I'll transform my place, and that will concatenate out. So that is Michael Bloomberg, who was doing that in New York and now has got trying to do that everywhere. So building it from local. So that is another way. So then when we step back and we look what our community puts in its models, we don't have any of that stuff there, which is sort of the bread and butter of how we connect actions today with near-term aspects. So this is taken from one of my colleagues, Karen Fisher-Vanden, and it's just actually a very rich schematic of the things and the feedbacks that are in collections of integrated assessment models. So she goes from human activities to emissions to changes of concentrations to climate impacts to response to the physical systems, sectoral productivities, so the different regions and sectors, and how those then affect economic losses, and then we may respond with adaptation coping strategies, geoengineering, sequestration mitigation strategies, and sort of the key is investment in R&D, which is a little bit related to the technology transformations, but none of the things that really do give you action at a distance are in these models. So what this talk is about is trying to take some baby steps towards thinking about those. So we're going to ask, how can near-term policy choices create policies that sustain over time? So we're going to think about policy feedbacks. And so this is based on this RAND report we did last year. And having laid out that broad spectrum of mechanisms, we're going to focus on one particular one. And a lot of collaborators. The first three are Rand colleagues. Ted Parsons at UCLA, there's a grad student of his at Michigan. Barry Ickes is an economist at Penn State, and this is a grad student of his who is now teaching in Denmark, who did really interesting paper, which is sort of the same theme here with the agent base, much sort of simpler, but much more closed form than what I'm going to show you today. Okay, so I'm going to talk about characteristics of policies that sustain over time. And this comes out of the political science history literature. I'll give you a framework for then thinking about how analytically we can essentially model this action at a distance, the long-term consequences of near-term actions, take you through our model set up trying to look at this, give you some results, and then some observations. Okay, so here's the question. Why do some reforms persist for decades while others do not? And this is a particular body of political science literature that looks at this question. And the basic setup, which we're going to reproduce in our modeling, is that policymakers have this moment where they can put a policy in place. It can be a really radical policy. You've got a majority, you put it in place, the public's behind you, you put this thing in place, and then your power to act dissipates. You've done your thing, the public is now interested in other stuff, and sometimes these changes persist and sometimes they don't. So again, this is looking at a US context, but the US Social Security system, the Voting Rights Act of the 1960s, the airline deregulation in the United States, these were all things rather radical at the time, which then have persisted for decades. The US goes through bouts of tax reform where we simplify the tax code, and that never persists. You make a big radical change and it's gone within a few years. Okay, and so what's the characteristics of those that persist and those that don't? Well, it turns out that if you look across these in political science theory, is that reforms that create constituencies that then favor the continuation of the reform tend to persist. So with Social Security, you get retirees. And you see this every time it's mentioned, change it. With voting rights, you've got new voters. And with airline deregulation, the airlines who hated it in the US before now are huge supporters because they've designed all their investments around it. Okay? But tax reform doesn't. Okay? I mean, you pass it, people's attention goes away, and the special interests eat it apart. So the question then is, how do we think about this creating constituency mechanism in the context of climate policy and how we shape climate policy? Okay, so let me now give you a framework for thinking about this idea of long-term policy analysis, how near-term actions shape long-term consequences. So long-term decisions are hard. People prefer gratification in the present, future. That's part of the whole discount rate debate. Deep uncertainty severs clear connection between what you do now and long-term consequences, and so we're not sure what's going to happen, so it tends to that's another actually contribution to the way discount rates works actually in behaviorally, is that since you're not sure that the consequences of what you do, you tend to discount the consequences, and you can show that in the lab. Whereas in problems where people are pretty confident they know the long-term consequences of what they do, they actually act very significantly. So people do tend to spend tons of money raising their children because they have a good sense that if you give them a good upbringing, that makes a difference over the decades. But they don't behave that where they're not sure of the connection. And then organizational constraints and arrangement can make it hard. This time inconsistency and the whole way policy debates are organized often around the idea of certainty. And then obviously there's this idea of surprise, black swans, which we know are out there, but we never quite get in our analysis. Okay, so what are long-term decisions? Here are two definitions, which I set up fundamentally as counters. So Larry Summers, former US Treasury Secretary, current decisions with distant consequences, in a paper he did a couple of years ago. Detlef Sprintz, colleague at PIC, defines long-term policy as ones that last generations, deep uncertainty, and focusing on public goods. We tend to take more of a consequentialist sort of definition, which is a long-term decision occurs when reflecting on things that happen in the future change what you do today. Okay, so you change what you do today in a fundamental way because of thinking long-term. And so if the long-term doesn't inform near-term choices, it's just a little bit strong entertainment. That's a quote at a workshop. So just to give you an example, your kid loves basketball, you want to make them happy. Short-term thinking is you build a basketball court in the backyard. Okay, long-term thinking is you want them to get a good education, get a basketball scholarship, so you buy the ball and save the rest for college. Okay? However, so that's for most people. There are those people that money is no object, your fun needs friends, so you build them the basketball court, and so the long-term decision goes away. It's just a short-term decision. So the point here is that long-term decisions are very contextual on what actually makes a difference in what you do now. Okay, so traditional decision analysis is often organized around what we call a predict and act framework. So the first thing you do is you characterize the uncertainty, then based on that, you rank your strategies, and then you do sensitivity analysis. And that's often implicit behind a lot of the way we do our modeling. So tomorrow we're going to be doing our scenario workshop and talk about other models. And this is now this definition of deep uncertainty, and then the setup for one suggestion, at least, for how to think about that. Long-term decisions have this notion of deep uncertainty where the parties to the decision don't know or don't agree on the model that relates action to consequence. So I do this, what happens? The probabilities, how likely is this? And if you take a decision that has this characteristic and tries to stick it into that box, things can go wrong. That there's this real pressure to underestimate the uncertainties, because if you start to take seriously how uncertain things are, and you do the sensitivity analysis every time you twiddle something, it changes the ranking. So that's not very helpful. Competing analyses can contribute to gridlock. If policy recommendations are predicated on forecasts, and if you don't like the policy, you attack the forecast, because the forecast is often more likely to be wrong than the policy. So you see that a lot. And then this idea that there's often a lot we know about a problem, which is not very predictive, but can help us sort out different, which policies are better than others. So much of our work is built on this idea of robust decision making, where we essentially do the analysis backwards, start with decision options, identify vulnerabilities, that is, futures where the policy works well and where it doesn't. And from that, you can assess alternatives and trade-offs. And so this is the framework I'm going to use in thinking about this question of how do these policy feedbacks contribute or not to sustainable policies, and what can we do, what does that mean for how we design policies? Okay. And so key attributes of this is that we're going to look over multiple views of the future, which multiple states, multiple probability distribution. We're going to think about policies which are robust, not ones that are optimal. And we're going to be very iterative, looking at vulnerability response, trying to identify better decisions. Okay, and just laying out now this in this more schematic diagram of how we actually go about this is you scope, you generate lots of cases, you do this process of discovering scenarios which illuminate the vulnerabilities where policies work not, and then you do the trade-off analysis. And we often do this in the context with stakeholders. This one is just essentially a desktop exercise. However, I want to make the point that, as Evelina, you mentioned in the introduction, we've done this actually in a lot of stakeholder exercises, and it works actually quite well. So this is a study we did for the federal agency and the state parties to what's called the Colorado Compact, which is how the 100-year-old agreement for divvying up the water in the Colorado River, which is about 40 million Americans at this point. Quite contentious, as Mark Twain said. Whiskey's for drinking, water's for fighting. And then the master plan for the state of Louisiana, for the master plan for sustainable coasts, was built with analytic facilitation using these methods. Okay, great. So let's now dive into this model. I'm going to take you on a tour of the pieces of this and then show you what it suggests. Okay, so this is an agent-based evolutionary model that is designed to look at the long-term effects of near-term policy choices, in particular with this idea of policy sustainability. So they're the pieces. We've got firms, and they're a single sector, and they compete on price. And they have two inputs. They have labor and carbon, contribute to production, and basically they compete on price. And their market size is affected by the carbon price and climate impacts, both things which make their market smaller. Then what firms do is they invest in R&D, and their big decision is whether they should emphasize labor productivity or reducing their carbon intensity, so carbon productivity. And they can allocate their R&D investments based on, between those two, and they're going to do that based on, in part, what they think future climate policy is going to be. Then you've got a government which sets the carbon price based on its best estimate of the social cost of carbon, so it's trying to do good. But it also gets lobbied by the firms, some of whom want the price to go up and some of whom want the price to go down. And the government is an agent that balances between those two influences. That's the cynical part. Governments sometimes do that, right? Okay. And the model is built on the evolutionary economics work of Giovanni Dossi and then Mark Borsuk at Dartmouth, and that's the bulk of it. And then the thing we did here is add this game theoretic model from the trade literature, which by two economists who are thinking about the situations where tariffs go up and down, which is again based on firms lobbying the government on how open they want their markets to be. Okay, so, and the key thing in this model is that we're going to look at near-term choices regarding the policy architecture and how that affects how these interactions play out over time. Okay, so this goes back to the political science model. You've got a moment that you get to create your climate policy, which is going to include the institutional architecture. Okay, and then it's out of your hands and it just runs. And the future government civil servants are going to do their best to do what you told them to do, and the firms are going to lobby based on what they think the government's going to do, and this whole thing runs. And the question is, what do you do with your moment of organizing the policy? Okay, so this is the bubble diagram. So we've got a climate, firms, market, government, and technology. And this part is the evolutionary economics part. And then we've got this game theoretic competition between the government and the firms over what the climate policy ought to be within the framework we've set up. Okay, so let me take you through the pieces of this to give you a sense of what it does. Oh, and then one more part of this robust decision making is we often find it really useful to organize a problem into these four boxes, which we call ExLRM. And in some sense, this is just basic decision structuring, basic decision analysis, but it actually turns out to be immensely useful both for your own thinking and in talking to stakeholders. But so, what are you trying to achieve? What are the actions under your control that help you get to your goal? What are the uncertain factors, things you don't control, which may influence your ability to get to your goals? And then what sort of relationships, which we then stick in this simulation model, connect what you want to do with the uncertainties you get to the outcomes. And so for this, so let me now using that structure, go through this. So the simulation model, essentially we give L's to the government, which structures how the government behaves. And then we're interested in the market and the climate outcomes. And the R is the thing in the middle. And here's our list of the things we're going to do. The policy levers are going to be a carbon price, think a carbon tax only. And then we're going to look at grandfathering, and we're going to look at revenue recycling as adjuncts to the carbon tax. And these are both things that one can do when you put the tax in place. We're going to pay attention to things like total emissions, socially optimum carbon tax. The decarbonization rate, in some sense, is our main measure because we're trying to make that fast, trying to do the 2C. of Celine's paper. And then we're going to look at market shares and carbon price to compare to the socially optimum price. So is it lower or higher? I'm not going to go through all this, but we have a very simple climate model, but it's sensitive. How sensitive is climate to emissions and how the impacts depend on that. And the government is characterized by this policy architecture and then its willingness to deviate from the social optimum and its ability to figure out what the social optimum is. Firms have a whole bunch of characteristics, which I'll touch on when I describe what they do, but basically they're differentiated by what sort of technology opportunities they have, what their production structure is, that sort of thing. Then there is this fundamental set of uncertainties, which is what are the opportunities out there for labor enhancing technology and for carbon intensity reducing technology, and then some basic price elasticities and growth rate of the economy. And then the model is essentially this evolutionary economics framework with this game theoretic part. And then the other innovation we did here is we have two types of R&D. Most of these evolutionary economic models just have a single type of R&D, but we're interested in different technology pathways. Okay, so just now to take you through these things, the climate model is designed to be as absolutely simple as you could possibly imagine, and all it does is track cumulative emissions, and then there's damages as a function of cumulative emissions. That's all the climate model does. And so, and then it's got little bumps in it, and it can do things like that. And we scale this over, a huge range of different damages and calibrate it to various damage functions in the literature. The total market, again, this is pretty simple, but damages decrease the size of the market, so that's bad. Carbon price can squeeze the market depending on the elasticities. So that can be a little bit bad, it could be really bad. And then the firms see demand, which they're trying to fill. Oh, and then let's see what else is important there. And then the characteristic of an evolutionary economics model is it pays lots of attention to industry structure, which is why we chose it. And in particular, firms, exit and enter the market, or they go bankrupt, or they come into the market with new opportunities, which is sort of the technology dynamism in this model. Just again, basically firms compete on price, and so if your price is consistently lower than your competitors, your market share grows, and the firms try to grow their market share. And then firms gain revenue from sales, and then they have a whole bunch of things that they can invest in. And so basically, this is the competition for their R&D investments, and is the thing that guides and constrains the technology pathways. So they pay their debt, they join a lobby, then they need to produce goods for sale, which costs money. Then they can do R&D, and if they have money left over after all those things, they can change their capital stock. And it's essentially when they do this that it changes their price structure and affects their ability to compete. Okay, then the firms allocate their money to R&D based upon what they think future climate policy is going to be. So the government announces what it thinks the social cost of carbon is, the price trajectory it's going to follow. The firms then observe each period whether or not the government is following that social cost of carbon, whether it's above or below. They form their own expectations about what they think the future price of carbon is going to be, and they invest accordingly in carbon reducing or labor essentially reducing technology. And then firms can either be technology leaders, or they can invest their money in imitating others. And this is all sort of standard evolutionary economics with the addition of this carbon price, which affects how they allocate their innovation. So this is the most complicated chart I'm going to show you, which is essentially how we think, how technology evolution is modeled in this model. So basically, there's a carbon productivity and a labor productivity frontier, and then there's a random draw for improving the state of the art in those. And each firm has its own state of the art, which, depending on how much they imitate, moves close to the other state of the art. And the point of all this is that there's a separate, depending on how much you invest in labor versus carbon, you can have a chance to do much better in labor productivity or much better in carbon productivity. So if you don't invest, you don't get a very good draw. If you invest, you may or may not get a good draw, depending on what the technology potential looks like. So, and this just shows this is a firm that's investing everything in improving its carbon intensity. So it's got a distribution like this, where it has a possibility to do really well, but doesn't get to do very much in labor. And this one is one that's pretty much the opposite, which is focused mostly in labor and very little on carbon. So it just gives you a sense of the difference. The essential point here is firms can choose different strategies, which give them then very different set of incentives when it comes to thinking about climate policy. Okay, and then what the government does is it receives the carbon taxes. It announces its policy, estimates the social cost of carbon, and then broadcasts that so everybody knows what it thinks it is. And the government, though, has imperfect information, so it can get surprised. And so here's an actual damage function, but with this jump in it, and the government doesn't realize that jump is there, so it's projecting based on the dashed line, and it doesn't get perfect information about the jump until it gets sufficiently close to it. And how close you need to be to the abrupt change before you know it's there accurately is one of the uncertainties that we look over. And so it would underprice the social cost of carbon, or it may overprice it. So we go through. Okay, so and then so then this is the sort of the key to this is that the firms join together then to lobby the government over what the carbon price ought to be. And so we've forced firms to pick one lobby or the other, so there's no free riding. And there's a big literature on coalition formation, but we're not doing that here. Firms have to join a lobby. And then there's a game theoretic competition, and this is this model from the trade literature adapted here, where basically firms have a willingness to pay for a certain policy outcome, and the richer they are, the more money they have to invest in trying to achieve that policy outcome. And then the government has essentially, a stickiness for the social optimum, and which is basically characterized by this parabola, which may be very, flat, in which case the government is very unsticky, or maybe very steep, in which case it is. And essentially, you go through this little game theoretic competition. This is the lobby that wants the carbon price high. Essentially, this is how willing it is to pay for a high price. This is the one that wants it low. And depending on the resources, and these curves are based on the resource of the lobby and how much they benefit. This collection of firms benefits from a change in carbon price, which will have to do with how much their carbon intensity differs from the other lobby. The firms fight it out, and the government sets the carbon price accordingly. So, so this just starts to show how this works in one representative case. So this would be the carbon price with perfect information, there were no lobbying. Here's with imperfect information but no lobbying. If only the high carbon price existed, you'd have a much higher carbon price. If only the low carbon lobby existed, you would have this price. And in this particular case, this lobby wins out and the price stays low until about 50 years in, where it jumps up. Okay, so there's a lot of different price trajectories in the model. The one that governs the evolution of the system would be this one, which the firms will look at to make their expectations, and then this one is which they actually see and respond to. Okay, and where do you get the dynamics from this? So this shows all the different firms in the model, the market share of all the different firms in the model in this one run, and the red ones want a high carbon price, the blue ones want a low carbon price. This shows, this is just a test case with a simple socially optimal tax, and then the light is the negotiated tax, and this shows the resulting carbon intensities. And so what you get here is, in the beginning there are two sets of identical firms, one favoring low, one high carbon price. Initially, in this run, the high carbon price firms win and bid up the price, and then all the low carbon price firms exit the market because basically the high price forces them out. And then that breaks up the lobby, because now among the ones that currently all used to all favor the high price, now they're competing with each other, not the others, and so they splinter, and that causes the price to go down. And there's for a long time it's the low carbon price firms winning, and then eventually you get this market shift, and the high carbon price firm takes off, and the carbon intensity goes way down. Okay, so this is what the model does when it runs, and as is typical of these agent-based models, it's sort of all over the place. So what do you do with a model like this? It's got interesting feedbacks, but it does a lot of stuff. Okay, so let me show you now. Now I'm going to connect this model back to what I was telling you about long-term uncertain policy analysis under deep uncertainty, and try to draw something useful from this model. Okay, so this is the essential thing we're looking at. So I'm considering the following scenario. The government implements a small carbon tax. Some firms invest in low-emitting capital and lobby for a more stringent tax. Others lobby for a less stringent tax. And there's sort of two paths into the future. One is the carbon price rises over time. Firms increasingly invest in low-emitting technology, and you get this transition to a low-emitting state. And the other is that carbon prices get stuck, because you got this whole low carbon lobby which hold it down. And so the question is, what are the characteristics of the system and the policy which puts you in that world as opposed to that one consistently? Okay, so to answer that, we first want to calibrate this simulation. So this model has 32 uncertain input parameters, that govern climate, the ability of the government to detect and respond to climate change, and how sticky it is, all these economic parameters. So it's got a whole bunch of parameters. So the first thing we do is we note that 19 of these characterize things that have happened in the past, and we can think of as at least reasonably characteristic of an economy. So we do a big statistical sample of 15,000 futures, run the model, and then we run it through a filter of the past 50 years, so essentially a hindcast. Okay, and we keep 10 maximally diverse, in the sense of very different input parameters, that are all reasonable fits to economic growth, decarbonisation rates, local productivity changes, and the market share of low carbon, the high carbon price lobby. And so we get these 10 maximally diverse futures. Okay, so that gives us essentially our fit of the model to the past. Then we take the other parameters, which relate to things that are hard to do a hindcast on. So future climate, the future competition between the lobbying behavior of the government. Though my student who's involved in this has actually gotten a huge lobbying database and is actually now trying to calibrate the lobbying part of this, but that's not in this. And the future technology, and then we take a couple of futures there, and so we put that all together, and so part of it's calibrated, part of it's just a range of estimates of future, though the climate part is calibrated against a wide range of future climate estimates, and we end up with a set of 20,000 futures for testing policy again. So we've got this big soup of different, essentially 20,000 different parameterized models, and we're going to test policies against them. Okay, So the first thing you can ask is which of those parameters make a difference. Here, so you just do a basic sensitivity analysis, one at a time sensitivity analysis on those parameters, and not surprisingly, you get, this is then how much the variance in the decarbonization rate across these 20,000 futures depends on these parameters varied one at a time. And so the ones that affect the opportunity, essentially the R&D opportunities for carbon reducing technology tend to most strongly explain differences in the decarbonization rate. That's not too surprising. This has to do with the shape of the distribution. So that's one at a time sensitivity analysis gives you that. Then I'm not going to say too much about this tonight because this is what I'm going to talk about tomorrow, but this is this scenario discovery technique, which you can think of here as a all at a time or global sensitivity analysis. And so if you ask the question, under what conditions does the actual carbon tax in the model differ strongly from the socially optimum carbon tax in the model? So the couple of graphs I showed you earlier where there's the social optimum tax and the realized tax, it turns out that the situations where those are really different are those where there are strong technology opportunities for low carbon R&D, or the low carbon R&D on low carbon technologies can yield significant benefits, and the government is susceptible to lobbying. This is essentially the slope of that parabola. So the first thing you get out of this is that thinking about these policy feedbacks are important when there are technology opportunities and the government is susceptible to lobbying. So we could do a show of hands of how many people think those are not implausible situations that describe the world we live in, but I won't do that. But I would argue that is not implausible set of assumptions about the world we live in, that there's lots of technology opportunities, but the government can be lobbied. And so that, thinking about these feedbacks are important. Okay, so let me show you results of the model. We consider our three policy over now. This is a slightly different experimental design. We can discuss why between this and that, but it's essentially the same as I showed you before. But we've simplified a little bit to do these experiments. And so we're going to look across a range of climate damage impacts, how sensitive the economy is to essentially energy and carbon prices, and the technology rates. These are essentially informed by the scenario discovery I just showed you. We're going to look at carbon price only, carbon price with grandfathering, carbon price with revenue recycling, and run it through our simulation. And it turns out to be convenient to show you plots which are laid out into these four scenarios. Okay, so I'm going to show you a couple of plots like this. So in the upper left-hand corner there's rich opportunities for both labor and carbon R&D. So if you invest in carbon R&D, you can make big changes, really reduce your carbon intensity. If you reduce in labor R&D, you can really reduce increase your labor productivity. Here, there's rich opportunities for carbon, but poor for labor. Here, there's rich for labor, but poor for carbon. And here, there's poor for both labor and carbon. Okay? So, the first thing we try is a grandfathering policy. And we thought this would be interesting because under the Clean Air Act in the US, grandfathering actually made it a lot easier to get the legislation passed. And there it's actually had some bad effects in terms of capital turnover. But here we find it really doesn't do much of anything at all. So what I'm showing you is for our four scenarios, rich opportunities for both types of R&D, rich carbon R&D, but poor for labor, poor for both, good for labor, bad for carbon. And the blue is just the plain tax, and then the red is the tax with grandfathering. And this is a standard bar and whisker across our several thousand futures. There's really not much difference at all. And that kind of surprised us, but it turns out what happens is that for grandfathering doesn't really make much of a difference when there's market entry and exit, which wasn't the case with the Clean Air Act in the US because that was all utilities where there was very little market entry and exit. But what happens here is that the new firms that come into the market don't have their capital grandfathered, so they care a lot about what the carbon price is. In fact, they care a lot more because there are some firms that are grandfathered in, and that basically totally cancels out the whole effect. So grandfathering, at least in this context, doesn't seem to make any difference at all. It turns out revenue recycling has a really significant effect. And so again, here are 4 scenarios. And what you get is that when there are high opportunities for carbon R&D, you get about consistently about 1 percentage point increase in the decarbonization rate over the century we run this thing. When you here the revenue recycling, this is you collect the carbon tax and you give it back to firms proportional to their production. So you tax them basically proportional to their carbon emissions, and you give them back, return it to them proportional to emission to production. So what that does is it reduces the effect of the carbon tax on the market share, and essentially is a subsidy from high emitting firms to low emitting firms. But that way it's not actually surprising that it makes a big difference, but it does. And if you go back to Celine's chart, a 1% difference in decarbonization rate over a century actually makes a pretty big difference. And so this policy makes a big difference. It plays out. This is now looking at what the market share for the high carbon price lobby, for the plain tax grandfathering and the tax recycling, and it's basically it makes across all these scenarios makes a really big difference in shifting a lot of firms to favoring a much higher carbon tax than you get otherwise. And what we're doing right now is the work we're doing right now is looking at this and seeing in how many of these cases does it overcommit and give you a much higher carbon tax than the social optimum, because that would also be a failure case. And then figuring out how to tune the tax to reduce both the overtax and the undertax, which looks possible to do, though we haven't quite gotten it all working yet. And this just shows, the decarbonization rate for the 4 scenarios, and what this shows. So this is the plain tax and the recycled tax for the good technology opportunities, but the policy difference. So you see that actually the technology landscape is at least as important as sort of what the world gives you in terms of technology opportunities, but the policy makes a significant difference. So just some quick observations. The first is that we've made the first steps at making a laboratory, simulation laboratory for thinking about this question: how does a policy architecture, something you could actually do right now, how does that affect long-term evolution? So we show that it can make a difference, but there's huge numbers of limitations. So there's no public opinion in this model, so the whole notion of changing norms isn't here, and that's presumably really important. I mean, a lot of social change is built around that, but it's not here. We only look at a set of policies so far. Probably should put that on the norms too. And this is, obviously a gigantic. This is one market and no geography, so that's important. And then also this is really focused on national policies and not how you would play these same ideas out internationally, which presumably would include trade and rules and other things. But I think this basic architecture is expandable in a lot of different directions. So just in summary, this is try to introduce this idea of policy sustainability, which is generally untreated in many quantitative analyses, though most policymakers kind of have that in the back of the mind. There's some mayor on the radio once. He says, the nice thing about being a mayor is, actually I've got 2 in my family, that you can build something and know that in 100 years people go by and see your name on the building, right? And so, policymakers actually do think about these things. So our analysis suggests that under these 2 conditions, in fact, considering these feedbacks, at least under the set of circumstances we looked at, can actually be really important in the long-term outcomes. We were able to distinguish some near-term choices that make a difference and others that don't. And so we think, this approach, you could actually do that. And even with these kind of squirrely models, which do all sorts of wild things, as I showed you when you looked at the individual cases, using this analytic approach of using models, you can see that over a very wide range of assumptions, these things are true. And so, the argument is that this sort of agent-based game theoretic simulation approach used in an appropriate framework for using models, which is scanning over many, many thousands of futures and then looking at common patterns across it, can help us understand the connection between actionable near-term emission reduction policy choices and this idea of long-term outcomes. And I think I have a thank you. Yeah, some more information. Thank you. And look forward to your questions.
Thanks a lot.
You're welcome.
Rob. And I would like to open the floor for questions and answers. When you have a question, please do introduce yourself.
Yeah.
And I heard actually in another event someone saying that a question is a sentence with a question mark.
So are people allowed to make comments? Isn't this a form of question? Yeah.
Please.
Yeah.
I'm Neil Strachan from the UCL-Energy Institute. Rob, in terms of the energy climate policy landscape, do you think your sort of one-time policy formulation is correct? There's nice examples of, Social Security or airlines.
Yeah.
Here in the UK, 2008, we had this big push.
Yeah.
We're going to do the Climate Change Act, and here we are in 2014. We seem to be revisiting some of that.
Yeah.
So just in terms of iterative policy making.
Yeah, and I'm a big, proponent of, iterative policy making. No, I mean, clearly this is a stylization in many dimensions, and one is it builds on the one moment of influence, and so no, I mean, I think climate policy is an ongoing process, but I think it's also, so much of the analysis has this sort of pays no attention to the policy time dimension at all, and kind of assumes policymakers have equivalent control over what happens now and have control what happens decades from now, and we kind of think about long-term goals and long-term paths. So this is in some sense quite intentionally the opposite extreme. You've got a moment to do something and then the system runs all by itself and people are going to be automatons from that point forward, which is again obviously a stylization, but I think it's actually a helpful one I think it's a helpful one because so much of analysis ignores the time inconsistency problems and that the time dimension, and this is a first step, and I think clearly you'd want to build from here, but I think laying that out, laying out this end of the spectrum is useful.
So in the beginning when you had your diagram with the 4 quadrants,
Yeah.
you talked about it was carbon price, and then we've got these variants with grandfathering.
Yeah.
I wondered if y'all have thought at all about different overall federal policies that could potentially get you to the same end.
Yeah.
Outside of carbon price, if you could speak to that.
Yeah. My student, Steve Isley, was one of the names there. He's doing his dissertation on trying to look at differences between taxes and then cap and trade structures, which is actually how we got into this. So he's working on that. The Sarah Polburn, who I mentioned at the beginning, she did a simple 2-step decision model, which again very stylized, but looked at what is essentially a carbon price, which is set each time period, and then some stylized mechanism, think of it as a cap and trade system, where there are both long and short-term permits. And so what she found there, which was really interesting, was that if the with just the tax or just short-term permits, you get this sort of competition that we saw here, and she didn't look at recycling or anything like that, but you get carbon price which is lower than the social optimum over the two periods. If you add a certain number of these long-term permits, you get firms, think of banks, which buy up the long-term permits and in the second period lobby to keep the next allocation of the short-term permits very low, which increases the value of their long-term permits, and so you actually get a much higher carbon price over time. And then actually really interestingly, sort of the exact counter what you get in the standard environmental economics literature is that it turns out that if you vary the government, that the thing that looks like a tax varies strongly with the change in government. If the change in government is a change in the slope of that parabola, which defines their adherence to the social optimum, and the one with the long-term permits, the carbon price is much more insensitive to the change in government, and all that changes the amount of money that goes into lobbying. So that's a cynical part. But anyway, so we have tried to use this on other mechanisms, and then starting to think about things like renewable tax credits and stuff like that. So so I think this is a rich playing field to think about, not only so the underbelly of the choices, but basic policy architectures. Yeah. Yeah.
One of the interesting things about your analysis was the way in which you're suggesting that you split the high carbon lobby from the low carbon lobby, and they have an ability to influence the sort of divergence between the social cost and the actual cost.
Yeah.
I think a real sort of feature of the economy is that kind of size of those respective lobbies has changed over time.
Yeah.
And also, some of the way the government interacts with the lobby, it can actually influence it. So within the UK, we're developing a renewables lobby, which obviously is part of the high carbon price lobby. And to what extent do you think your model actually captures that kind of change in the relative bargaining powers, and how exactly do you work out the kind of calibration of those two models?
Yeah, no, they're good questions. The particular model we use comes out of the trade literature, trade economics, where I think it does a reasonable job of capturing the dynamics in that sector. So we just picked it up and used it over here. So we have much less empirical evidence how it works in this different sector. So it's at this point it's an analogy. Again, my student has put together this database and is starting to get some initial results that in fact it's not an unreasonable, at least you can calibrate it to some interactions in the United States. So let me leave it at that. I mean, it's worked pretty well in one sector. We're transforming it, bringing it into another sector. Started to look at, try to look at it empirically, and some initial good results, but a long way to go on that.
Within your model, as the economy decarbonises, is there a strengthening of the high carbon price lobby?
Well, yeah, I mean, the answer is yes or no. Yeah, I mean, so. There is for a while, but then, as firms drop out, then the composition of the lobby shifts. But what happens is as the social cost of carbon goes up, then it becomes harder. That tends to carry the price, so that the competition goes back and forth. But yeah, yeah, let me just leave it at that. Yeah.
John Silver
Yeah.
from the much.
Yeah.
Completely lost the thread of what I was going to ask.
Okay.
I'll change it around slightly. As far as the lobbying is concerned, you've got a model that's still very much US-centric.
Yeah.
Do you see it transferring across to the UK or to smaller countries? And I think I'd actually sort of take away from the lobbying for a moment and let's look at the model as a whole.
Yeah.
The US is big enough to sort of stand alone and do things, and to some extent, clearly the rest of the world has an impact on it. But it's, things it does almost stand alone.
Yeah.
If you're the UK or something, and you start your sort of industry competing, it's really what's happening from other nations that's going to really drive what happens.
Yeah. So I think, I didn't say it was a U.S. model, but it basically is. So I think probably, carrying this to say to look at a particular European country's policy would be more complicated because you would have to look at that government's policy within a much a market that affects it much more. In some sense, it would be analogous to trying to do it for an individual state within the U.S. So I think using this to look at another country's policy, like the UK's government policy, would be you'd have to make a more complicated, more actor model. As I think to look at international questions. I mean, questions about international climate policy, you'd probably need more actors than we've got here.
I would like to ask about two complications which might be possible about the model, or if you have thought about them. The first would be, I was really interested about the type of kind of the two input factors, labour and carbon. And in the first instance, like where's energy?
Okay, yeah.
And I was thinking, okay, how do you reduce carbon today without reducing energy? If you have thought about this kind of, whether putting the third kind of impact factor or carbon as a function of energy reduction. So this would be the first application. And then the second would be, so far as I understood, the only governmental influence really goes, the connection between the government and the firms go through the price.
Right.
And I was wondering if you modeled, or if you think about modeling some sort of kind of direct R&D incentives within the model.
We've thought about both of those. So to just generalize your question a little bit, which is in part, you relate to yours, it's like, so what if you were now going to make this, more complicated, where's the best way to go? So we didn't put in an R&D policy, though that's clearly something that the government would do, because the connection between government spending and what you actually get technologically is hard to model and hard to get much data on. And so we explicitly thought about and just chose to say the government's doing a reasonable R&D policy, and and the distribution of technology opportunities is all contingent on a reasonable government R&D policy. And obviously, if the government was investing nothing in R&D, that would look different. But so we didn't think that was a particularly valuable way to go. It would clearly be really valuable to add another sector. And we've run carbon together with energy. I mean, we smush them together, so there's no separate investments in, say, energy efficiency and changing the fuel mix. And so that would be one way. And clearly, there's some interesting reasons to disconnect those, because policies are different in the two, and they may have very different temporal dynamics, and they also respond to shocks differently. I mean, we get energy shocks, which might make a huge difference, right? And so that might be a reason to pull energy out. And so that would, that's sort of high on the list of, a to-do. But another way to go would be to, say, look at a capital goods sector or a financial sector, which would also have interesting temporal dynamics. And for the question back there, it was the ability to look at a financial sector that gave you that interesting thing about the advantage of long-term permits. And so I think of the two things you mentioned, R&D is low on the list of additions. Energy, a separate energy sector, separate from carbon, or energy R&D separate from carbon, is potentially really interesting, but don't have a final decision on whether that's more interesting than, say, a finance sector or capital goods sectors, or transportation and electricity. I mean, this is all sort of electricity, markets. So you might have different markets as well. So anyway, there's a lot of ways you could enrich it. It kind of depends on what what policies you want to look at.
Okay, so if anyone does not have more questions, I would like to invite you for drinks and thanks.
Well, thank you very much.
Thanks.